The question is asking position of a particle change with time as x is equal to this much. Find the magnitude of the following. Velocity at t is equal to 5 seconds and average velocity in first 5 seconds. So two things I need to determine. Let's solve it. So in the question, first I need to determine velocity. The value of position or else displacement is given as x is equal to 2t square plus 3t plus 4. Now differentiate it. So dx upon dt value is going to be 2 times of 2t plus 3. So this is going to be my velocity. So velocity is going to be 4t plus 4. Now velocity I need to determine at t is equal to 5 seconds. So if I put t is equal to 5, I am getting 4 5s are 20 plus 3, 23. So 23 meter per second. So 23 meter per second is going to be the answer. 23 meter per second. Now in the second part, we need to determine average velocity. So for average velocity, we need total displacement and total time. Average velocity we need to determine for first 5 seconds. Okay. So first I am calculating my position after 5 seconds. So instead of t, I am putting 5. So I am getting this thing. Let's solve this. So 5 square 25, 25 into 2, 50. 3 5s are 15 plus 4. So I am getting 69. Now velocity at 0 second or initial velocity. So initial velocity I am getting once I put the value of t as 0. So this thing is going to be 4. So overall displacement would be final value minus initial value. So this is going to be 65 meter and time taken is 5 seconds. So time taken is 5 seconds. Now average velocity I need to determine. So average velocity is total displacement upon total time. So this thing is going to be 13 meter per second. Discuss about instantaneous velocity. The test define how fast the particle move at a particular instant of time. Average velocity, average speed, instantaneous velocity, or instantaneous speed. So instantaneous velocity define how fast the particle move at a particular instant of time. Option C is the correct answer. So how we calculate instantaneous velocity? Well, it's very easy. What you need to do, simply differentiate. Okay. So x I already have. So I am differentiating this. So dx upon dt value is going to be 3 times of 2t. So instantaneous velocity equation is going to be 6t. Next question. The question is, again, I need to determine its velocity. So it will have two velocity, one in x direction, other in y direction. Okay. So let's calculate each one of them. So dx upon dt value is going to be 3 times of 2t because obviously differentiation of t square is 2t. So velocity in x direction is 60. In the same manner, dy upon dt value is going to be 2 into 1. So velocity in y direction is 2. X direction velocity is dependent on t. So it is non-uniform in nature. Y direction velocity is independent of t. So it is independent. So it is uniform velocity. Next question. The question is, the position of an object is given by itna, then find speed or instantaneous velocity. Okay, so first I am differentiating the things. So dx upon dt value is going to be 2t plus 6. Okay, 6 into 1 plus 0. So this is going to be my equation of velocity. Now, instantaneous velocity, I need to define first when t is equal to 0. So if I put t is equal to 0 here, I am getting 6 meter per second. This is my first answer. Now I am putting t is equal to 1. So if I put t is equal to 1, I am getting 8 meter per second. So this is going to be the answer of second part. And last, t is equal to 3 seconds. So 2 into 3 plus 6. So this thing is going to be 12 meter per second. So for first part, answer is 6 meter per second. For second part, 8 meter per second. For third part, 12 meter per second. Understand concept of acceleration and its types. A motorist traveling at a constant velocity of 15 meter per second cross a red signal. In order to chase him down, the police officer must dash his velocity. So obviously the police officer must speed up his velocity. So when you speed up any object velocity, in another word, you are accelerating the object, right? So what is acceleration, by the way? So let's understand this by car example. So in car, we have 3 pedals. One is accelerator, which increase the velocity of car. The rate of change of velocity is called acceleration. So velocity change with time. Now, on a busy road, the velocity of the vehicle change with time. We already know. Now, the formula for acceleration is change in velocity upon time. So now let's understand this change. Change means difference in velocity. So acceleration can be written down as final velocity minus initial velocity divided by time. Final velocity is velocity after some time, while initial velocity is velocity in the beginning. So acceleration is represented by A, initial velocity is U, final velocity is V, and time is represented in T. So acceleration can be written as A is equal to V minus U whole divided by T. And its unit in MKS system is meter per second square, and in CGS system it is centimeter upon second square. Okay. Now, types of acceleration. So acceleration can be positive, negative, and zero. When plane taking off, in this case, plane speed up its speed, right? So this is positive acceleration. Okay. In positive acceleration, velocity increase. When plane land, it speed down, so it has negative acceleration. In negative acceleration, velocity decrease. Okay. It is also known as retardation or deceleration. Plane moving with constant speed. It is neither increasing its speed or decreasing it. So plane is moving with constant speed or zero acceleration. In zero acceleration, velocity remains constant. Now we have 2 formula of acceleration. First one is d2x upon dt square. So if you have equation of displacement, first you divide, you will get velocity. Again, you will divide, you will get acceleration. And there is one more formula. This is a v dv upon dx. Sometimes what happens, we get velocity equation in terms of x. So if you have this scenario, then you will use this formula for acceleration calculation. So this is going to be the complete scenario. If you have displacement equation and you differentiate it, you will get velocity. Again, you differentiate, you will get acceleration. If you have acceleration equation and if you integrate, you will get velocity. Again, if you integrate, you will get displacement. Let's try some question. Acceleration is the dash quantity. Is it scalar, vector, neither scalar nor vector, both scalar and vector? So the correct answer is vector. Acceleration is a vector quantity. The distance covered by a moving body is directly proportional to the square of its time. The acceleration of the body is increasing, decreasing, zero, or constant. In this case, the acceleration is constant. How? Let me tell you. See, we know second equation of Newton, which says S equals to ut plus half at square. Let's suppose body start from rest. So in this case, this equation will look like this one. Now the condition is the distance traveled by the moving body, which means S is directly proportional to the square of its time, So this condition only hold when acceleration remain constant, because we already know that in case of constant acceleration, we can use kinematics equation, right? So here we shortly say acceleration is constant. If acceleration is constant, then only distance is directly proportional to square of time. Let's try this question. First, I am discussing its first part. Magnitude of acceleration I need to determine. Displacement equation is given. So displacement equation is this much. Now I need to somehow figure out acceleration. So first I am differentiating it. So dx upon dt, and change in displacement upon change in time is velocity. So if you differentiate it, you will get 3t square minus 2t plus 5. So velocity equation would look like 3t square minus 4t plus 5. Now again differentiate it. So you will get dv upon dt, change in velocity upon change in time, which is acceleration. So 3t square, you can write it as 2t minus 4, and differentiation of t is 1 and 5 is 0. So this becomes acceleration. So acceleration equation is 6t minus 4. Now I need to determine acceleration at t is equal to 5 seconds. So I am replacing t is equal to 5 seconds here. 6 5s are 30 minus 4, 26 meter per second square. Now in the second part, I need to determine average acceleration. So average acceleration means total velocity, net velocity divided by time, right? So first I am discussing its velocity at 5 seconds. So I have velocity equation this one. So instead of t, I am replacing 5. Let's solve this. So 5 square 25, 25 3s are 75 minus 4 5s are 20 plus 5. So 80 minus 20, 60. Now let's figure out velocity at 0. So if you replace 0 here, you will get 5. So overall velocity or net velocity is going to be 60 minus 5, 55 meter per second, and time taken in this case is 5 seconds. So overall time is given as 5 seconds. Now what I need to determine? Average acceleration. So average acceleration is going to be net velocity divided by total time. So this is going to be 11 meter per second square. A particle move along x-axis and its position is given by this way. Find the acceleration at t is equal to 2 seconds. Okay, so acceleration I need to determine. dx upon dt. So this thing is going to be 3 minus 4t. Again differentiate this. So d2x upon d2 square. d2x upon dt square. So this is going to be minus 4. So minus 4 meter per second square. Option B is the correct answer. The initial velocity of a particle is u and the acceleration a is given by this way. Which of the following relation is valid? Okay. So using acceleration, I'll have to reach to velocity. So the value of acceleration is given as alpha t raised to the power this way. Acceleration I can write as dv upon dt, change in velocity upon change in time, or else the value of dv is going to be this way. Now let's integrate this. So 0, sorry, not 0, from u to v. Initial velocity is u, final velocity is v. And here the value of time goes from 0 to t. Integration of dv is obviously v and u. Alpha I can take common. Integration of t raised to the power 3 upon 2 is this one. T raised to the power 5 upon 2 upon 5 upon. And now replace the value here. If you replace the value, you will get b minus u equal to alpha t raised to the power 5 upon 2 minus 0 whole divided by 5 upon 2, or else v minus u. V minus u is equal to 2 alpha upon 5 into t raised to the power 5 upon 2. Now the value of v I can write as plus u plus 2 alpha t raised to the power 5 upon 2 whole divided by 5. So option C is going to be the correct answer. The motion of the particle along a straight line is described by the equation this. The retardation of the particle when its velocity becomes 0. So first let's determine its velocity. So dx upon dt. So this thing is going to be 0 plus 12 minus 3t square. Its velocity becomes 0, right? So first let's make its velocity as 0. So 12 minus 3t square, or else 3t square is equal to 12. T square value is going to be 4. The value of t is going to be 2. Now I have time. At t is equal to 2 seconds, they were asking retardation. Okay. So my velocity equation is 12 minus 3t square. Let's differentiate it. So dv upon dt equal to 0 minus 60. Instead of t, I am replacing 2. So my retardation value is going to be minus 12 meter per second square. Option D is the correct answer. Let's try this question. It is a PYQ in the year of 2022. So the question is dx upon dt value I need to determine. T is equal to this thing has been given. So t minus 4 is equal to under root x. Now taking square on both sides. So the value of x is going to be t square plus 16 minus 8t. Let's differentiate it. So dx upon dt value is 2t minus 8. In this question, they were asking dx upon dt at t is equal to 4 seconds. So write t is equal to 4. So 2 into 4 minus 8, 0. So 0 is going to be the answer for this. Next question on your screen. The position of a particle as a function of time t is given as this one. When the particle attains 0 acceleration, then its velocity will be. So first I need to determine its acceleration. For that, I am differentiating the things. Okay, so the value of x is given to me as 80 plus bt square minus ct to the power 3. Now let's differentiate it. So dx upon dt value is a plus 2bt minus 3c t square. Again differentiate it, so you will get acceleration. So acceleration value is 2b minus 6ct. Now they asking velocity when acceleration is 0. So put acceleration as 0. 6ct is equal to 2b. The value of t is going to be 2b upon 6c, 6c, right? So 2 ones are 2, 2 threes are 6. So this thing is going to be b upon 3c. The value of time is b upon 3c when its acceleration is 0. At that time, they were interested in velocity. Okay. So the equation of velocity I already have. I am replacing the value here. So the equation of velocity is this much. And here I am replacing the value of t. The value of t is b upon 3c, b upon 3c whole square. Let's solve this. So a plus 2b square upon 3c minus 3c into b square upon 9c square. C and c get cancelled. 3 threes are 9. So a plus 2b square upon 3c minus b square upon 3c. Now you can assume 1 in the denominator, and eventually 3c is going to be the LCM. So 3ac plus 2b square minus b square. So finally the answer is going to be this one. Okay. So that is going to be the answer. Next question. If velocity of a body related to displacement x is given by this, then the acceleration of the body is. This question is also a PYQ of IIT mains. So this time velocity is given to me in the function of x. So in this case, acceleration has formula this one. A is equal to b dv upon dx. So let's solve this one. So velocity is given to me as root of 5000 plus 24x. So what I am doing, I am taking square on both sides. So this part gets cancelled. So the value of b square is going to be 5000 plus 24x. Let's differentiate it. So I am getting 2b dv is equal to 0 plus 24 dx. So 2 times of b dv is equal to 24 dx, or else b dv upon dx value is going to be 24 upon 2 or else 12. b dv upon dx is nothing but a. So the value of a is going to be 12 meter per second square. That would be the answer. A particle moves along a straight line OX. At time t in second, the distance x in meter of the particle from O is given by this. How long would the particle travel before coming to rest? Okay, so first let's figure out when it comes to rest. So for that, what I did, I make velocity equation first, and then I put that velocity equation as 0 and will determine the value of t. So dx upon dt dx upon dt. So dx upon dt value is going to be 0 plus 12 minus 3t square. Make this as 0. So 12 minus 3t square, or else 3t square is equal to 12. t square is equal to 4. The value of t is going to be 2. So at 2 seconds, the velocity becomes 0 or object comes into rest. Now we need to check how long would the particle travel. Okay, so overall distance we need to determine. Now I know after 2 seconds particles comes to rest. So put t is equal to 2 seconds here. So after 2 seconds, my particle will cover this amount of distance. Okay, let's solve this. So 40 plus 12 to the 24 minus 8, 32 plus 24, 6, 5, 56 meter. So option C is going to be the correct answer. Next question. The velocity of a body depends on time according to the equation this. The body is undergoing and you have four options. So first, let's determine its acceleration. So to determine its acceleration, I need to differentiate this. So dv upon dt is equal to 2t upon 10 plus 0. So my acceleration is going to be t by 5. 2 ones are 2, 2 5s are 10. So as you can see, my acceleration depends on t. So it has non-uniform acceleration. Option C is the correct answer. Okay, this question is asked in NEET 2016. Two car P and Q start from a point at the same time in a straight line and their position are represented by this and that. At what time do the car have the same velocity? So what you need to do, differentiate this, you will get velocity of P, differentiate this, you will get velocity of Q, make them equal and figure out the value of T. Okay, so how you will do it? I am showing to you. So first I am differentiating my P. So if you differentiate position of P, you will get A plus 2BT. Okay. Now let's differentiate Q. So if you differentiate Q, you will get F minus 2T. They were interested in same velocity. So make this one and this one as equal or else this one and this one equal. So if you make this thing equal, you will get this. Now let's figure out the value of T. So 2BT plus 2T is equal to F minus A. You can take T as a common. So you will get 2B plus 2 is equal to F minus A. Finally, the value of T is going to be F minus A divided by 2B plus 2. You can choose 2 as a common. So B plus 1. Which option is satisfying? D. So D is going to be the correct answer. A particle of unit mass undergoes one-dimensional motion such that its velocity vary according to this, where beta and n are constant and x is a position of the particle. The acceleration of the particle as a function of x is given by. So I already told you acceleration in term of x can be written as this way. Okay. So now I need to determine dv upon dx. So let's differentiate this. So dv upon dx value is going to be beta minus 2n x raised to the power minus 2n minus 1. So I have dv upon dx. Let's put this value here. So acceleration is equal to b. The value of b is already given, beta x raised to the power minus 2n, and the value of dv upon dx just now I have calculated. Okay. So finally, I am getting the answer as beta square minus 2n beta square and x raised to the power minus 2n minus 2n minus 4n minus 1. So option B satisfy the scenario. So option B is going to be the correct answer.